Here today is that we're going to talk about how you can rearrange things. How many different ways can you pull things and put things in order? We're going to talk about what this means. What does that mean in math?
It's a line happy
Upside down.
Factorial. All right, it's factorial. Do you know what factorial means? If I say
it's always true.
If I say it's 4 factorial, good. All right, so this is one symbol that we will see a lot.
Well, it's finding the number of options.
Yeah. Okay, it's kind of what it is. What he was saying is it's kind of like working with numbers of options. For example, how many sandwiches can you make from the following selections? We have ham, turkey, roast beef, and salami. Bless you. White, wheat, and rye bread.
7 exclamation point. 7 factorial, I
Well, it's not the.
It's 4 times 3.
Why?
Because you have 4 different kind of meats that can go with 3 different kinds of toast. So, so if one kind of meat would have 3 options, the second kind of meat would have 3 options, and then the third kind of meat would have 3 options, and then the fourth kind of meat would have 3 options. You add up all
Okay,
those
so you've done a little bit of this before.
Yeah. But
Okay.
you can have multiple meats on a sandwich.
I was going to actually say make a diagram, and I had some fun stuff here. I had, I had turkey, an actual turkey, a turkey on white.
It's white on turkey.
But yeah, the fundamental counting principles, like you guys just all explained. Morning, Judah.
Good morning. I have 2 very expensive calculators in my office.
Oh, you do? I'll come down there next hour and grab it.
Yeah, right now it's set.
Cool. Thank you very much.
calculator.
You never know. It might be. He's been looking for it for a long time. So what's happening here, you guys already said this, if you're trying to figure out just plain old options, how many ways can you, one event can occur within another event, selecting sandwich meats, selecting sandwich breads, how many do you have of this times how many you have of that. And it works the same way if there's more than 3. So if you have 4 meats to choose from, 3 breads to choose from, 2 toppings to choose from, 6 pieces of vegetables to choose from, and so on and so on. You can continuously compound that stuff through. It's a whole lot of words here for the following of 4 times 3 equals 12. Okay. Now, when we use that, you look at it for how many different ways can you get bad guys. When you're talking, when you have the police detectives, you just got robbed. Poor Tom got his calculator stolen. But he saw who done it.
Who did done it?
So he saw who done it. So he's sitting down with Lockhart. And they're going through, they're going through the Facebooks, like a book of faces. No, actually. Yes.
A craft ton.
A crack ton. That is the name. Yes. So what happens here? How many possible bad guys can you get? Well, if there's 195 hairlines, 99 eyes, 89 of those, 105 of these, and 74 of those, it gives you a big number of possibilities.
Yeah, 1,499,999.
Some big. The answer is big number.
Oh, but if you know their eyes.
But if you know a couple of them, it starts to dwindle itself down. So in this case here, if you happen to recognize, you remember who stole it by just their nose and their eyes. You saw just that much because they were covered.
And 1,515,150.
Like this. It was what? It was Lena? It was probably Lena. So all you have to do is, if you recognize the eyes and or the nose and the eyes, those become 1s, and then the rest of them fill themselves in. And we were what? We knew the eyes and the nose, so that means it's still 195, 105, and 74.
1,515,150. Substantially smaller than 1.3 times
105, sorry. 105 and 74. So this is still big.
But less big.
Oh, we'll call it less big number.
You can call the first one supersized,
You can call
and
it
then the
Big
next
Mac.
one is large.
I know, you've done
So
this.
what it's looking at here, guys, is again, you've probably seen this. This is not that bad. So let's put a little bit together, and I don't know if you've gotten this far before about configuring options on like license plates and things. What's in plate in New York? So let's say that in New York you have 3 digits and 3 letters.
Okay.
Well, how many different options can you get? Well, if it's
Crap.
digits, if it's digits, how many digits are there?
26.
Digits.
It's
Ten.
10 digits, and how many letters?
26.
So
Wouldn't it, yeah, it would.
for the first part then, if you can repeat them. Okay.
17,560,000.
That's how you would set that one up, right? Because you have 10 options for the first one, 10 options for the next one, 10 options for the next, 26, 26, and 26. Yes, you could do that. This is kind of the idea, and then what if you can't repeat them? What happens?
It's times 9
Times 7 times
Good.
26.
Good. Good. That's kind of the same idea along with the lottery. The possible values you can get for the lottery. So in part B, what happens now is that you have 10 for the first choice, that one's gone, then there's 9 left, then there's 8, then the 26, 25, and 24. That's the same premise of all the different possibilities you can get when they do like the Powerball stuff. There's 56 numbers, I believe. You pick 5 of them, and then you get the Powerball number. So what would happen, you have 56 times 55 times 54 times 50, and so on. And then you'd have to go back up to 56, because that's a separate ball. That's why they say that there's more possibilities of that than there probably are people. You have a better chance of falling out of bed and being eaten by a tiger, living in DeKalb, than winning that. When you start going scratchers. That's the whole idea, that the complete lunacy that you're gonna win is just so improbable.
But you won.
Yes, that's right, with my Powerball simulator. I did win that one day, but it took me
A lot of years.
a lot of years, yes. You know,
We should have the Powerball simulator running.
I do have one.
Yeah, you showed us at the beginning of the year, but then no one understood because you did it last year.
How are we going to?
So we're gonna do it again?
I'll pull it up. I'll just let it run.
It's like a simulator where it goes to work. Crap, winner, lose.
All right, well, let's think about this one. How many different ways can you arrange the letters A, B, and C? Why?
You have 3 options for the first one, put that number 2, and then only 1.
Correct. And this is where the options, where it's not 9, you guys would think, oh, I can square it, or cube it. 3 times 3 times 3. What happens here is this is what we call a permutation. How many different ways can you arrange something? Well, if you put the first letter, put A first, there's only 2 other spots left. And you have 2 places to put B, and only 1 place left to put C. This is what they call a permutation.
Which is the exclamation.
Correct. So when you're using the permutation, when we're trying to figure out a specific order, this is where the order matters of like arrangement, if you will. If I wanted to figure out how many different ways can we arrange where you guys are sitting. Well, today is kind of a bad example because there's nobody here. But if we had, we had everybody here, let's say we had all 30, if we have 35 people in a classroom, if you take, once you place the first person, they can't go anywhere else. There's 34 spots for the next person. There's 33 spots for the following, and so on and so on. So the order in which you place things, when it matters, is called permutation. There is another one that we're going to talk about tomorrow called a combination, where the order does not matter. It's just a little bit different. Yes, sir?
Where's the permutation button on
There is one, and there is a factorial button on your calculator.
Really?
If you go to math,
Okay.
And I think you hit, what number, which one is it? Is it
It's
under,
probability.
is it under probability? I thought it was,
Number four.
there you go.
1 times 10 to the 4th.
If you hit,
40th.
if you go to
Oh, you have
math
to go
over 4, then that's what you, that's how you get the exclamation point. Okay. So in this case here, this permutation, since there's 3, it would be 3 factorial, and that's where you get 3 times 2 is 1. Now, when you're trying to,
Overflow, what?
now think about this, let's mix this in a little bit differently. You have 12 skiers for freestyle skiing, aerial competition. Yeah, sounds awesome and radical. How many different ways can the 12 skiers finish, assuming there's no ties? Well, what would you press on your calculator?
The exclamation point.
Well, the 12 exclamation point. Remember, you're not yelling at the number 12.
12? Why'd you do that?
So when you put that in your calculator,
You get super big number.
Super big numbers.
so 12 factorial gives us, there's 479 million possible ways that 12 people can finish. So, and that, you start to think about it, it's crazy. Okay? It's crazy. But now think about how many different ways can only 3 of them finish first, second, and third?
12 times 3.
No. This is where the order starts to matter. Very good. What's happening here is that order matters when you're going in terms of first, second, and third place. You know that someone's got to win, someone's going to come in second, someone's going to come in third. If someone wins, there's no one else can win, right? If someone takes second, nobody else can take second. If someone takes third, nobody else can take third. So this is where that order matters. And this is where it gets interesting. So let's talk about this one again. We have a total of 12 skiers. So you get 12 skiers, and you want the top 3 places. How many different ways you can do that? Well, for the one person, you get 12, and then for the second person would be 11 left, and then there's 10 left. What that stands for is 12 permute 3.
12 exclamation point.
N permute R. How many ways can you choose or pick 3 out of 12 when order matters? What your calculator is doing when there actually is a button that says this is you have 12 possible divided by 12 minus, yeah. Got a formula. It's doing that. Because what is 12 factorial? It's 12 times 11 times 10 times 9 all the way down to 1. What's 12 minus 3? 9 factorial would be 9 times 8, 9, 7. So it cancels itself out, right? So you get this 12 times 11 times 10 times 9. That's where these drop out, and you're left with just that. So if you're trying to figure out the way that the top 3 finishers could go, it would just be 12 times 11 times 10. Substantially less possible ways to do it. Who done it? It was the colonel with the candlestick in the library. Colonel who? Sanders.
Mustard.
Mustard. Thank you. I love that movie. We talked about that not too long ago.
The game.
The movie was very good.
Play the game.
I played the game.
is so good.
Have you seen the show?
The movie.
There's an improv show.
Did you watch all the
It's pretty
Oh, no.
funny.
changed endings?
Yeah, that's where things get fun. Yes.
Wait, what are you?
There's a movie called Clue.
The It's really scary if you're really little.
Yeah, but it's also
Oh.
like made in the '70s, so now most people think it's just terrible anyway.
Again, there's a button for this, for the permission.
Oh, you don't have to do like 12 exclamation point over 9 exclamation.
Oh my gosh, it's right there.
There's a button for you, NPR. So what, oh, actually, you can write this in. What I would do here is I would do 12 math over 2, 3. 12 permute 3 and hit enter. And that's the same thing as 12 times 11 times 10. Again, it's very, very straightforward. So if you have, okay, look ahead at these example next. Again, the formula for this one, it's not that you can't do it by hand, but remember permutations are for, yeah, why would you? Permutations are for when order matters. Permutations are for when order is going to matter. That's the big idea. That's why we talk about distinct. How many distinct possibilities are there? Okay. Order matters. So real fast example, and I'll probably just give you a couple of problems here. Oh wait, we have to talk about non-repeating. You have 10 colleges you're looking to choose from, but before you decide you want to visit some or all of them, how many different ways can you visit 6 of the colleges, and then how many different ways can you visit all 10?
10 times 9 is 7.
Well, let's say you're not going to NCAA. Let's say you're just Joe Schmo that's not going to get a scholarship. Okay. So you have 10 different colleges. How many different ways can you visit 6 of them? Well, the order has to matter here, because if you go pick one first, you can't go to it again. You got to go to someplace.
10 times 9, would it be 10?
Well, how many are you choosing from here?
10 minus 4.
Well, you're overthinking it. Aren't you just choosing 6 to go to?
Yeah.
So would it be
10?
5 over 4?
No.
10 times 9 times 8 times 7 times 6 times 5.
There's 10 colleges. You're looking to go to 6 of them.
Oh,
Just put in your calculator.
No, that's what I said.
Yes. Oh wait, yeah, because you said over the 4. Yeah. Sorry, I was overthinking it myself then. Yeah. But you just put in your calculator, how many different ways can you go? A lot.
big number.
1,051 for 151,200. A ton of save money for kids.
You're going to do that.
Well,
There's a lot of driving there. Okay? Now, if you're going to visit all 10 of them,
10 for me, 10, or would it just
3 million.
and then exclamation?
that 10 exclamation, I believe, right? Because I believe,
3,628,000.
again, it's still a lot. It's just not a lot of fun. That's a lot of driving. Nobody wants to drive like that.
This is why you fly point.
Right. So even in this case here, you could have done it as 10 choose 10, or excuse me, 10 permute 10. Because if you wrote it out that way, isn't it the same value? 10p10 is the same thing as 10 factorial. Because if you wrote out via the formula, that would be 10 factorial over 10 minus 10 factorial. And this is kind of a weird thing. 0 factorial is 1.
Kind of like 0 or anything with 0 power.
Yeah. It's kind of like that. So that's why this works. It's where it just works out to be the same value.
Okay.
Now, the weirdest thing that we're going to look at here is distinguishing possible permutations if you have repeated values in words. This is kind of like password breaking, password codes, things like that.
Sweet, we can do this now too.
Let's go for all type of illegal stuff.
No,
Gambling
no,
is
gambling,
not
big piles of cocaine, all that kind of stuff. Well, we can't do that because Lena doesn't get one. Now,
I thought it was math.
oh yeah, I thought Lena was she dealing math?
She does both.
Oh, she's moving up.
No, she's just making more money doing both expanding the business.
It's a smart business plan. So, in this case here, what's happening is, if they take a word, for example, we'll take the word Ohio. The number of letters is 4. How many letters are repeated?
Oh, no, none.
Well, how many times is it repeated, I should say?
One is repeated twice.
One is repeated twice. Ohio. O is repeated twice. So how many? That means what you would do is you take the number 4, because there's 4 letters, and repeat it however many times. Since O is repeated twice, it becomes 2 factorial.
So would it be 4 times 2 times?
So your answer would be 4 factorial over 2 factorial, otherwise known as 4p2.
So what if you're defining like the H's, would it just be 1 factorial?
No, because you're using how many times has it been repeated. H isn't
Oh.
repeated.
Oh. Okay.
So here it just, you get 4 times 3, which is 12. How many different ways can you rearrange those letters? So 12.
But that Mississippi is a man.
With the Mississippi, you have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. Well, let's see. S is repeated 1, 2, 3, 4 times. I is repeated 4 times. And the P is repeated twice. I believe that's where we set that up.
It's disgusting.
It is disgusting. But you guys remember when we first learned how to spell Mississippi? Weren't you so proud of yourselves? Yeah, M-I-S-S-I-S-S-I-P-P-I. You said that. Now, again, when you put this in your calculator, you can just write it out just like that with the fraction bar and put the factorial in it, and it's just going to come right out for you. Oops, wrong one.
This is the most labor-intensive thing.
Computers.
Calculator.
Yeah.
Yeah, we should get like you do that.
So calculate the numbers on the
You put it next to it, it's going to imply that it's multiplication.
So it's not like sometimes you need to have the parentheses for like a fraction, but because it's kind of funky.
No, in this case, with the factorial symbol like that, it's just, when you put them next to each other, it's showing.
That's a lot of ways to take points.
3, 4, 6, 5,
Yes, sir.
Okay.
So today we're just looking at very simple counting principles. Permutations are dealing with how many ways can you pick things when the order matters. So let me give you a couple of these to try for tonight.
You know what I just realized? No, they were,
Okay.
we were taping, so they
This,
recorded all of our.
I will tell you one thing, this looks like it's a lot, but it's just pressing some buttons on your calculator, and if it takes you more than 3 minutes to do all those, that first group there, it means you had to go find other batteries for your calculator. This really shouldn't take more than 10 minutes, probably. Okay? I hope. Then we'll get in, I think a combination's take a little bit.
taking out.
Yeah.